I've been interested in how the brain gets wired. In humans, for kids that have their sleep disturbed during critical windows of development, there are clearly outsized neurobehavioral consequences. Okay, now, aside from work in humans, we now know that fish sleep more earlier in life, flies sleep more earlier in life, and sleep is developmentally regulated in worms as well. What's the purpose of sleep in early life? Because there's critical periods of plasticity. I mean, as you might have expected, mostly talking about flies. So, I'm going to talk about flies. All right, so it never ceases to amaze me that flies recapitulate changes to sleep throughout their lifespan that we experience as well. Young flies sleep more. As flies age, their sleep becomes more fragmented. Again, every animal seems to sleep more when they're young, and we don't know anything about what controls that process. Fly sleep was first characterized around 2000. No one has ever looked at anything but adults. And 90% of the neurons in the adult brain are born during this time when you have this experimentally tractable system that's behaving and doing all kinds of things that you can study. So this is the larvalog. You're looking at these animals moving around. That we found with quiescent episodes greater than about 30 seconds, 75% of the time they retract their head. Okay, so the next thing we wanted to make sure is that this is rapidly reversible.
As we all know, he works with both Drosophila and Mexican blind cavefish. He uses these two organisms to understand the evolutionary and genetic effects of sleep.
So many of us think we can do everything at once, but we're constantly choosing between behaviors. If a fly is well fed, it might seek out a mate, and if it's starved, it might ignore that mate in order to go out and look for food. What is it about the brain that's fundamentally similar that can confer completely different behavioral choices? At this point, I knew this gene was required for the integration of these processes. This unique model, the Mexican cavefish, which they've lost their pigment, they've lost their eyes. But if you look at why those morphological changes occurred, the cave environment is very different. Animals have very few predators. You can see there's almost nothing for the animals to eat. This wake-promoting neuropeptide hypocretin increased in cavefish. This is this wake-promoting gene. We see an increase in cell number. It's actually more neuropeptide per cell.